4A, and today I am showing my second video about building a K-means clustering model. Thank you! This code performs K-means clustering on the iris dataset, a classic machine learning dataset containing measurements of 150 iris flowers across 3 species, Setosa, versicolor, and virginica. Let's summarize the code and its output. Step 1. Import libraries and load data. The code begins by importing necessary libraries. Example, NumPy for numerical operations, Pandas for data manipulation, matplotlib.pyplot for plotting, sklearn.cluster for the K-means algorithm, sklearn.datasets to load the iris dataset, sklearn.preprocessing for data scaling, standard scaler, sklearn.decomposition for dimensionality reduction. The iris dataset is loaded, separating features X from target labels Y. The target labels represent the true species of each iris flower and are used only for latter comparison, not in the unsupervised K-means clustering itself. Step 2. Data preprocessing. The data is standardized using standard scaler. This is a crucial preprocessing step for K-means clustering because it ensures that all features contribute equally to the distance calculations. K-means is sensitive to feature scaling. Without standardization, features with larger values will dominate a distance metric, leading to potentially inaccurate results. Step 3. K-means clustering. K-means clustering is performed with n_clusters equals 3 because there are 3 iris species, and random_state equals 42 for reproducibility. The algorithm iteratively assigns data points to clusters based on their proximity to cluster centroids, updating the centroids until convergence. The resulting clusters array contains the cluster assignments for each data point, and centers contains the coordinates of the final cluster centroid. Step 4. 2D visualization using PCA. Because the iris dataset has 4 features, it's difficult to visualize directly. Principal component analysis (PCA) is used to reduce the dimensionality to 2 principal components, capturing the most significant variance in the data. The data points and cluster centroids are then projected onto this 2D PCA space. A scatter plot is generated where each point's color represents its assigned cluster, and red X mark the cluster centroids. Step 5. Summary of code and output. The code successfully performs K-means clustering on the iris dataset, demonstrating the basic steps involved: data loading, preprocessing, clustering, and visualization. The 2D scatter plot visually represents the resulting clusters, allowing for a basic interpretation of how the algorithm grouped the data points.